All right, welcome back, fifth graders. Hopefully you took the time to answer questions 6, 7, and 8 on your own so that you are able to check your answers against what I'm going to give you here right now. I'm not going to go through the process of those. I did enough of that with the previous problem, so I'm just simply going to write down the answers and what they should be, and then talk more specifically about the decimal point placement. So for number 6, 54 or 5.4 times 5.2 should end up with an answer of 28.08, and again we have two numbers in the problem behind the decimal point, two numbers behind the decimal point in the answer. Those two numbers need to match up. For number 7, either 0.774 or 0.774, and again making sure that you have 3 decimal point place values in the problem, so 3 decimal point place values in the answer. And then the last one, number 8, should be 1.402. Again, 3 numbers behind the decimal point in the problem, so 3 of them behind the decimal point in the answer. All right, so again, hopefully you guys practice those problems on your own before watching the second video. If you didn't, again guys, please take advantage of the tools and the opportunities that we're giving you. Now there are still 3 full rows of questions that you can answer on this page, so if it's something you're still struggling with, maybe contact your teacher and ask them to go through a problem or two with you. Go through some of those problems on your own, have your parents check your work. Those kinds of things would all be great practice opportunities. Now, we also have these same types of problems put into story problems. Now, because we are dealing with multiplication, one of the tricky aspects of story problems, guys, is determining what kind of problem we're trying to solve. That's not the case when we are in a unit like this where we're only working on multiplication. So we know that each of these problems is going to be a multiplication problem. And so I'm not going to spend a ton of time. I'm just going to go through 1 or 2 problems here. But the other aspect, the other thing that I really want to go over with is actually on the next page. So I'm going to quickly go through a problem or two here and then focus on the opportunities to make problems a little easier on the next page, or the operations or the properties of multiplication problems. So Maggie is training to run a 6-mile race. Her training program has her increase her weekly long run each week. This week she ran 4.5 miles. Next week she will run 1.3 times as far as she did this week. How far will she run next week? So maybe the bigger problem or the bigger issue with this problem is that you need to make sure you are multiplying the correct numbers. Now they've given us a 6-mile race up here, so the number 6 is involved in this problem, but we need to be able to understand that 6 actually has nothing to do with the math itself. This problem will become 4.5 times the 1.3. Simply stated here, she ran 4.5. She will run 1.3 times as far next week. So the problem that we are going to solve here is going to be 4.5 times 1.3. And that again just basically becomes 45 times 3. So I go through the process here. I'll do the normal standard algorithm. 5 times 3 is 15. 3 times 4 is 12, plus the one I just regrouped is 13. Done with the 3, done with this 1. Make sure I put my 0 placeholder there. 5 times 1 is 5. 4 times 1 is 4. So I'm looking at those for my 2 partial products. I add those 2 together. 5 plus 0 is 5. 5 plus 3 is 8. 4 plus 1 is 5. 2 numbers behind the decimal point in my problem, 2 numbers behind the decimal point in my answer, so I should have an answer of 5.85 miles. Okay, and again, because it is a story problem, we really want to stress that we have a label on them. Now, a lot of our answers on our exit tickets, guys, we're trying to eliminate some of those silly mistakes and eliminate some of those things. So we, in a lot of cases, are adding those. If you have a story problem, we've already added those labels. But just so you guys know that it is extremely important that we do add those things. All right, how about problem number 22? Hank earned $140.95. Pelham earned 0.8 times as much as Hank did. How much did Pelham earn? So again, even though he earned less, Pelham will earn less than Hank. we still are doing this as a multiplication problem, again, because we see 0.8 times. So as we go over here to the side to work this problem out, now this is a really unique one in a sense, guys, that this is a 5-digit number times a 1-digit number. All right, so this is kind of a unique problem and a unique situation based on that. We don't do a lot of 5-digit problems, but it is what it is. When we're dealing with money, oftentimes we will end up with numbers this large. So 5-digit times 1, I just go through the process of multiplying like I normally would. 5 times 8 is 40. 9 times 8 is 72, plus the 4 I just carried is 76. 8 times 0 is 0, plus the 7 that I just added is 7. 8 times 4 is 32, carry the 3. 8 times 1 is 8, plus the 3 I just carried is 11. So I've got a really long string of numbers here, okay? But now I will need to count. This is where it gets kind of fishy and kind of weird on this problem, is we're dealing with money, right? How much did Pelham earn? So we know it's going to be money. So in our mind, we automatically think, well, 2 numbers behind the decimal point. But if we take a look at it here, it's going to make sense here in a little bit. 1, 2, 3 numbers in the problem behind the decimal point, which means I need to have the same thing in my answer. So 1, 2, and 3 numbers behind the decimal point. The decimal point is going to go between the 2 and the 7. And you might say, well, Mr. Mace, we've got 3 numbers behind the decimal point then. But if we are really honest with ourselves, having a 0 at the end of a decimal number doesn't mean anything, doesn't change anything. So the answer for this one should be $112.76. And again, putting the $sign for our label. That is our answer for that one. So it might look weird to start out with, but when we really boil it down, it becomes a pretty straightforward problem. So again, you've got some more examples on here if you're struggling with that concept, but really not a difficult thing to do, guys. We're really just practicing 2-digit times 2-digit multiplication. We're practicing how to place a decimal point, and that's what this boils down to. All right, now I said I wanted to focus on the next page here. So as we take a look here, these are things that have been talked about. I know they've been talked about with you probably since early elementary school, but we do not really focus on the names and the terminologies, guys. The commutative, the associative, and the distributive, those are not as important for us as what those things actually mean and what they, how they can affect and impact our problems moving forward, how they can make our problems easier. Okay, so if I look at the commutative property, I don't need you to remember that we call it the commutative property, but we need you to understand that the order in which a problem is set up with multiplication and adding for that matter, it doesn't matter. A times B is going to be the same as B times A. So whether the A comes first or the B comes first, it does not impact the answer. So this just simply means that we can flip-flop the order. And that is an example for problem number 27. Okay, if we see 4.5a times 3.2b on this side, and now I look across the board and I see a is also on the back side of that equal sign, that simply means that the blank that I have here is also going to be b, which in this case is 3.2. All right, and we are simply flipping the order of those numbers. It's not any more challenging than that. I know a lot of students tend to struggle with that problem or those kinds of problems in particular, but once they figure it out, it's like, oh yeah, that makes sense. I can see why that's the case. Okay, and it's not hard to know. We've known that forever. If I write an addition problem and I say 6 plus 4, okay, 6 plus 4 is 10. Well, so is 4 plus 6. It does not matter the order that I put those two partners in. The associative property is the similar type of thing. Now we are going to rearrange the order in which we multiply a multi-step problem. So here we've got A times B inside parentheses, which would normally tell us to multiply that first and then multiply C at the end of that. Okay, but they're saying that you could still end up with the same answer if you switched the parentheses and did multiplying B times C first and then multiplied by A at the end. So you can change the order in which we multiply these numbers, and that comes in really handy when you're working with something like fractions, especially on the adding side of things where you've got something with a common denominator already. And I know we've done those kinds of problems throughout the course of this year already, but that's the associative property where we can change the order in which we answer a multi-step problem like that, if it's all adding or if it's all multiplication. And then the distributive property, I think is the most confusing, but it's also the most helpful, especially when we start working into the higher levels of algebra, guys. Okay, and that is stating that if we have a common variable or a common number, a common partner at this point, we've got an A in both parts of these problems, and so I can do it this way. I could multiply A times B, because by order of operations, that would mean I do this first, and then add the totals together. But if I notice that I'm multiplying by the same number, in this case, the same variable is A, I can rearrange what I'm doing, and I can add the B and the C together first, like they did right here, put a parenthesis around that, and then only have to multiply by A one time instead of 2 times. And so they're just regrouping and reorganizing the problem. You will end up with the same answer, and that's what we're trying to stress here. So as we look at the examples down below, I've already done problem number 27 for you. So if you look at problem number 80, or problem number 28, excuse me, we are missing the number 80 in that next problem, and that is an example of the associative property, where all we are really looking for here, it's possible that somebody is able to multiply the 80 times 72 easier, and so they want to do that and throw the parentheses around the first part of that problem instead of the second part of that problem. We will end up with the same answer. That is, again, the associative property, but we are not considering that the important part here, associative. Okay, that's not the important part of this. It is simply that we can do that. We can rearrange these things, and knowing that skill is going to help us in the long run. All right, and then the last one is what we looked at with that distributive property. All right, so we are looking here and seeing, okay, 7 times 3.7 times, so that's on the outside of the parentheses, times 3.8 plus 4.2 inside parentheses. Well, it can work both ways. I can either take it and I can combine it, or I can break it apart. And this is one of those situations where they're giving us the combined version and we are writing in the broken apart version. So again, you can see the common variable is 7, which is what's out front. And instead of doing the parentheses and adding those things together first, which would be the easier way if we really look at the problem, because combining 3.8 and 4.2 gets us to a nice easy answer of 8. Okay, that's going to combine to make 8, and everybody should know or have a pretty good idea of 7 times 8 is 56. Or I can solve it this way by doing the 2 separate decimal problems, 3.8 times 7 and 4.2 times 7, and still end up with an answer of 56 when I combine those two answers. All right, so not a major change, but it can become an easier problem if I'm doing the first version here. I can make that an easier problem by combining the like or unlike terms and leaving the like term out and then multiplying it at the end. Okay, so as I look at this last one here, the one I want to go over, I'm going to skip over 30, but I do want to look at problem number 31, because this is another one of those distributive properties, and I feel like this is the most valuable one for you. Here is the one where they're doing the distributive property in the opposite. They've got 2 separate multiplication problems, and we should see that we have a common partner. We've got a 3.2 here. So they're suggesting that why don't we just look and combine the 2 other partners and add them together first, because that's going to combine to make a nice easy answer of 10. Well, anybody knows fairly easily how to multiply by 10, so that makes that problem easier. And then I simply put the like term on the outside of that parentheses, so this becomes 3.2 times 10, and 3.2 times 10 simply gets us to an answer of 32. All right, so pretty straightforward stuff there. And again, we're not as concerned about you understanding the verbiage, the terminologies, the associative, the commutative, or the distributive, but it's more about the understanding how to solve, how to manipulate these numbers to solve these problems a little easier. All right? So that's where I'm going to leave off with this video, guys. If you have any questions, please make sure you're contacting your teachers. We are available and want to answer questions, so if something about this doesn't make sense, hopefully you can do that. There will be an exit ticket for you to solve on here. Please do your best, and if you need help, like I said, make sure you're asking.